Slide share visible. Okay, okay, yeah. So there is a question, right? We'll start with a question and then we'll cover that topic which will answer that question. We have already seen WS addressing last time, and WS addressing provides us two kinds of ways by which we can make our messages intelligent, right? So I hope you remember the concept of endpoint references and MI headers, right? MI headers are nothing but set of headers that can make your message as intelligence heavy as possible, right? So I'm going to start with the next topic. So let us look at the question. What is the side effect from benefits of loosely coupled messaging framework? So whenever we are having loose coupling between services, right? What is the negative side of that? Suppose the service sends a message, right? Now, will that service be keeping track of the message? What happened to that message afterwards? Are we going to keep track of that? Yes, it is just like fire and forget, right? So we don't keep track, and due to that, there can be reliability issues. Do you agree with this? There can be reliability issues, right? Because what if the message was lost, right, in the network and the receiver keeps on waiting? So we need a framework, or we need a standard, in other words, that can make our job easy, and that is WSRM, right? WS Reliable Messaging is one of the standard, or you can say specification, right? All the WS star terms are specifications, right? Designed in collaboration with multiple companies, right? And they have been widely accepted. So WSRM is one of the standard that can solve this question for us, right? So are you clear with the problem? What is the issue with loose coupling and what is the solution, right? Is that fine? Okay, I guess you are clear. Okay, let's continue. The benefits of loosely coupled messaging framework come at the cost of loss of control over the communication, right? We don't, or we are not having any control over the communication process, right? After a web service transmits a message, it has no way of knowing three things, right? What are the three aspects which we cannot know? The first is whether the message successfully arrived at the destination, right? So regarding the success, we don't know, right? And we can't even keep track, because if we do that, we will not be remaining loosely coupled, right? You will be remaining tightly coupled. And as you are remaining tightly coupled, statefulness will also arise, right? So a lot of problems will be arising, right? Second problem that we, or second issue that we cannot keep track of is whether the message failed to arrive. So suppose the message failed, right? And it requires a retransmission or not, right? Sometimes if you are making a let us say transaction, right? Generally we don't make a retransmission, right? Whenever we are making a transaction, and if it fails, do we make, or do we send that request automatically once again? Have you seen that behavior? Or the bank is asking you for your permission? Yes. Is the message is being sent automatically? Yes, it requires permission, right? So we need to know that if the message failed to reach the destination, then the receiver should let us know by some way that the message should be retransmitted, right? But as we are having loose coupling, right, receiver will never be letting you know, right, unless you are setting up a framework for that, right? The third thing that you will not be able to keep track of is sequence of messages, right? This is very important. If you remember that case study example, we had two services, invoice and accounts, right? Now, I also gave you that example that invoices can also be sent in a batch, right? At the end of the month, generally the companies have this policy. Suppose you have purchased 10 times from a particular vendor in a given month. So you will be submitting all the invoices in a batch, right? Now, if I want to set up a rule that every message containing a single invoice, every message containing a single invoice should reach in a sequence, right? Suppose, for example, I want that invoice number 1 should reach first, then invoice number 2, and invoice number 3, and so on. I don't want this kind of behavior, that invoice number 5 reaches first, and then invoice number, let us say, 3 reaches next, right? I don't want the messages to reach out of order, right? So, can we say that this is a possible requirement your provider might have, or your receiver might have, not the provider, right? Yes, in one sense, it is also a provider, we can say. But can we say that ordering is also one of the possible requirements in web service communication? I hope you are getting this point. Yes. Third point. Yes or no? Are you clear with this? Yeah. Okay. Okay. At least respond, right? So that I can go ahead. Okay. So there are three things we need to know. The first is, I want successful acknowledgement. I want successful acknowledgement. The second thing I want is a negative acknowledgement. I hope you are clear with this difference, right? You are studying computer networks also. So successful acknowledgement and negative acknowledgement, what will be the difference? Yes. What will be the difference between a successful acknowledgement versus negative acknowledgement? Yes, Urjit, I'm repeating the question. Difference between successful acknowledgement and negative acknowledgement. Negative means message is not received, correct, right? And successful means we are just notifying that I have received your message. Yes, Janil, that's correct regarding the negative, right? Successful means we are just confirming that the message has been received. Are you fine with this difference, right? So we want both kind of notifications, right? The third thing that I want is, if I am setting a constraint that the messages have to come in a specific order, and if the receiver is getting the messages out of order, then again, should we generate an exception kind of message if the messages are coming out of order? Yes or no? If we are setting a constraint that the message have to be in order, that is, message number 1 should be reaching first, message number 2 should be reaching next, and so on. And if you receive message number 3 before message 1 and 2, we need an acknowledgement system that can let the requester or that can let the sender know that you are sending the messages, but I am not receiving the message in sequence. Yes or no? Do we need this third acknowledgement system or not? I hope you are clear with the third situation, right? Okay. So these are the three kind of, you can say, notifications we require, right? And that is given to us by WS reliable messaging, right? So reliable messaging addresses certain concerns. Yes, yes, surely, Priyank, I'll repeat. Yes, surely. Yeah, I can give you an example. See, invoice and account. I think you know that example, right? Janil, Urjit, and Priyank. Invoice and account, right? So what if I'm sending invoices separately? That is one invoice with one message, right? And I'm setting a constraint that I have to receive invoice number 1 first, invoice number 2 next, invoice number 3, and so on, right? So they have to be received in the same order in which they are sent. Are you getting that requirement? They have to be received in the same order in which they are sent. Yes. Yeah. Priyank and Janil, are you clear? Yes. So I want to put that constraint. Okay. So now after setting that constraint, what if I'm directly receiving invoice 3, right? Is this a problem on the receiver side? What do you think? Yes, right. So if you have set a constraint that the messages have to be delivered in a sequence, if they are coming out of order, if they are being received out of order, we have to immediately let the sender know that I am not receiving the messages in sequence, right? You can check on your side. Are you clear with this now? Yes, General Priyank Urjit? Yes. Okay, so this is the third situation which we want. Okay, and we have a solution. WSRM can provide us the way for handling the situation, right? So basically, by establishing these three requirements, can I say that I'm improving the, or I'm, you can say, satisfying the quality assurance requirement of my framework, QA? Yes or no? Am I satisfying the quality assurance requirement? All of you have studied that in SE, right? That is, quality assurance is the most important thing, right? Even if you have designed a very good system, if it is not having good quality, right, it will be failing, right? So, reliable messaging ensures that we fulfill the quality assurance, and that can be applied to the entire activity management framework. That means to the entire solution, you can say. Fine. You can just have a look at this example. Service A is saying that I need to know if my message is arrived, right? And service B is replying that, how about I just tell you which messages I received? Are you getting the difference between these two? See, if service B starts replying for every message, will there be any problem? If service B starts replying for every message that you are sending, what will be the problem that you will be having? Which kind of MEP it will be? Yes, it will be having overhead, that's correct. But which kind of MEP that would be if you start replying for every message? I think you have studied MEPs in WCF also, and yesterday also you implemented that. Yes, request response. But request response is a burden, isn't it? Right? Because you have to wait for that reply and so on, right? So that is why this, yes, in some cases, agreed, right? So what service B is saying seems correct or not? How about I just tell you which messages I received, right? That seems appropriate, right? So that we can have minimum communication between services, right? So if you want to achieve this kind of requirement, we can use WSRM, right? WS reliable messaging. Are you getting the idea clear? What we are trying to do and what is the ultimate advantage of that, right? See, even if you are asked theory or MCQ does not matter. You should be clear with the concept, right? If you are clear with the concept, you can even ask an MCQ based on the theory, right? So I hope I'm making it as clear as possible, right? Okay. So next is WS reliable messaging provides us what kind of ways, that is this next slide covering, what kind of ways of handling reliability. So it is a framework which guarantees that service providers will be notified of the success or failure, right, of message transmission. So are we satisfying first two requirements? In first two requirements, what we require? Successful message and a negative acknowledgement, right? So that is satisfied, yes or no, by WSRM. What is the third aspect left? If we are sending messages in a sequence, right, then the messages sent with a specific sequence related rules will arrive as intended or generate a failure condition, right? So it has standard messaging, you can say, technology by which we can send, you can say, a success acknowledgement, you can send a failure acknowledgement, as well as you can also send out of order acknowledgement. We are going to see that in detail. What are the types of acknowledgement this framework supports? Okay. Now, this is an important paragraph, the last one. Reliable messaging does not employ a coordinator service to keep track of state of an activity, right? In this framework, we are not going to use coordinator, but all reliability rules will be implemented as SOAP headers within the message themselves, right? So what will be the benefit of this? Instead of storing the rules in a coordinator service, if we are storing them in a SOAP message, what will be the benefit of that? Or which principle will be better fulfilled if you are storing more things in messages rather than in the services? I have been discussing this from the first lecture, if you remember that. Yes, correct. Correct, right? As I told you in the first lecture, we will talk about loose coupling hundreds of times, right? So that is what is the essence over here. Fine. If you are making your message as much as intelligence heavy, right, you are making your services minimum coupled, right? So that is the concept of reliable messaging also. It does not enforce the services to remember the things, right? It is going to make sure that your headers in the SOAP message will contain all the information. Okay. So are you clear with this last paragraph? It actually covers the advantage of reliable messaging, right? So if you're asked that, you should be able to find out. Okay. Fine. Now in reliable messaging, we have 4 terms, right? If you remember, what are these? You can say these notations are known as. This circle is a service, but what about this square? Yes, it is a SOAP node, correct? Right? It is a SOAP node, but we are adding one more term to that. When you are using reliable messaging framework in your applications, the SOAP nodes are given the name as RM source and RM destination. Okay. So the service that is going to send the message will be known as application source, from where the message is being sent. Then the message will be actually transmitted over the network using RM source. As we all know, services are just logic. They cannot send the messages. They have to rely on the framework for sending the messages. Okay. And inside every framework, either you are using a .NET framework or a Java, you will be having a set of nodes available. Fine. So the message will be actually sent by RM source over the network or over the wire, you can say, right? And then RM destination would be receiving that, right? That is the receiver SOAP node. Okay. And finally, it will deliver that message to the application destination, which is the receiver service. So there are 4 terms and 4 operations in this. The first term is application source. The second term is RM source. The third term is RM destination. And the fourth term is application destination, right? Plus there are 3 operations. The first is send. The second is transmit. The third is receive. And fourth is not actually written over here, but fourth would be deliver, right? Because after RM destination receives that message, it has to deliver that to the application destination. So WSRM framework has 4 concepts and 4 operations. I'll again repeat: application source, RM source, RM destination, and application destination are 4, you can say, concepts that make sure that your services are reliable. And they use 4 operations: send, transmit, receive, and deliver. Okay, we'll be looking at the definition, but is the basic clear to you with this diagram? As we are studying the theory, we should know the definitions also, right? But still, I want to make sure that you are clear with the basics, right? Is that fine? Yes. Okay, let us continue. So what is application source? Yes, are SOAP nodes intelligent as SOAP messages? SOAP nodes are, you can say, they are, you can say, piece of code that generates the SOAP messages, right? As well as they are responsible for, you can say, sending the SOAP messages, right? So SOAP nodes will be writing the intelligent messages in the SOAP message. I'll repeat: SOAP nodes will be writing intelligent information in the SOAP message, right? So they are nothing but, again, piece of code plus some hardware. Are you getting that? they have to be instructed what has to be written in the SOAP header, right? So I won't say that they are intelligent, right? They will be doing based on their code, right, Urjit? Yes. Can't we just merge SOAP nodes so we don't need transmit function? Okay. Uh, so transmit is just an operation, right? While the message is over the network, we call that as a transmit operation, right? So SOAP node is a, you can say, code, while transmit is an operation. I think now you are clear with the difference, right? Yes. We can't merge these two things because transmit is an operation carried out by RM source. Is that fine, Udit? So that's why, see, every, you can say, notation in this diagram has an operation attached to it, right? So I will be discussing that in detail. So if still there is any doubt, it will be clear. Let us look at the definitions. Application source is the service or application logic that sends the message to RM source, right? So ultimately, who generates the SOAP message? It is the application source, that is your web service, right? Web service creates a message, right? But who will perform its transmission? It is the RM source. Is that point clear? Message has to be generated by a service, obviously, and all of you are experiencing that in WCF programming also, right? Whenever I think we have not had a lab on message contract, but you must have studied that, right? In message contract, can you customize what has to be written in the SOAP header and what has to be written in the SOAP body? Can we customize that? Yes, right? And where are we writing that information? That I'm going to send this in the header and this in the body. In the service or in the message? Where do we have that code? That I will insert ID inside the header, not in the body. Where that code is written? Inside the service? Yes, correct, right? I think all of you will agree to this, right? Try to relate this with WCF. It will be better to understand, right? Okay, so it is the service that actually creates the message, and then it is going to give it to the RM source. And RM source might be embedding some extra headers if required, right? So RM source would be making the message intelligent. You can say that, right? So RM source is a physical processor or node that performs the actual transmission, right? On wire, the message will be put by RM source. So be clear with this. Application source is just generating the message and transferring the burden on the RM source, that now you take up the message, transmit over the network, over the wire. Okay. And now I am free. Right. So why, what is the benefit of this two-level scheme? Why can't we make sure that application source itself sends the message? Why are we having SOAP nodes actually? Can anyone tell me? Yes. Again, the answer relates with the principles, right? If you leave the transmission logic as a responsibility to the service, can that service be more autonomous, or can it be, you can say, loosely coupled in one sense? If you are putting the burden of transmitting the message on the service itself, will you be violating the principles of autonomy, loose coupling, abstraction? Yes or no? I hope you are getting my point, right? So that is why we separate it out. Okay. So the transmission logic is handled by the node, while message generation is handled by the service. Okay. Fine. Next is RM destination. It represents the target processor or node. Don't confuse this processor with your CPU. It is just a processor in the sense it is going to process your message, right? In that sense, right? So it is target processor or node that receives the message and it subsequently delivers it to the application destination. Okay. Now in this, can you see these four terms or four operations in this slide? Where is the send operation? Where is the send operation? In the first paragraph, sorry, in the first definition, can we say that we have send operation? RM source adds some header, so RM destination removes that. Yes, yes, Kaushal. Nodes are capable of inserting and removal of header. If you remember that theory, which we studied in SOAP nodes, right? There are two types of SOAP nodes, active and you can say forwarding. Remember that classification? Forwarding intermediary can just take out the headers, while active can also insert new headers, right? So it is responsibility of nodes themselves, right? Yes, correct. Okay. So a send operation is associated with application source. Is that term clear to all? Send operation is associated with application source. Okay. Transmit operation is associated with transmit operation is associated with RM source. Correct. Correct. Receive operation is associated with RM destination, right? Receive operation, because you are going to receive that message, right? So that is with RM destination. And the operation which we did not depict in the diagram, actually the author has not kept it over here, but he has written in the theory, that is deliver operation, right? So deliver operation is associated with which entity? Application destination, correct, right? So now I hope I'm making sense, right? There are four concepts and four operations, right? They execute properly so that to make sure that your framework remains reliable. Okay, good. Let us go ahead. So that is written over here, what I explained. WS reliable messaging makes distinction between the parts of solution responsible for initiating the transmission and the parts that actually perform the transmission, right? So in this figure, which part initiates the transmission and which actually performs the transmission? Which part initiates the transmission, you can say? Application source, correct, correct. And which performs the transmission actually? RM source, right? So that is the concept of reliable messaging, right? Okay. Now observe this slide and just try to map send, receive, deliver, right? Just wait, I'm just pausing for a minute and let me know if you have any doubt with this operations, right? Okay, so is it clear? RM source, RM destination, application destination. Yes. Okay, I have a question. Header added by RM source, which make message intelligent, or it is added by application source? Yes, Dave. It depends upon the code that you are writing, right? See, in WCF, we are inserting the header by the service itself, right? I hope you agree to that, right? So it depends upon your code and the framework that you're using, right? Sometimes application source themselves can insert the header, and if you want your RM source to be adding the header, that is also possible. Okay, so it depends upon the framework you are using and the programming language that you are using, right? Clear? Okay, fine. Now we'll start with the actual contents, how we can make sure that our three requirements are fulfilled. That means I need a kind of acknowledgement system, right? For that, what are the requirements? Let us go through this slide. The first is sequence, right? Sequence establishes the order in which the message should be delivered, right? Now, if you want sequence requirement to be fulfilled, do I need to embed a unique identifier with every message? If I want that my messages should be sent in a specific sequence, do I need to embed a message ID? Yes, or sequence number, correct, right? So every message that is going to be a part of sequence will be labeled with a message number, right? And that message number will uniquely identify that message within the sequence. Like if you are sending multiple invoices, right, as individual SOAP messages. So every message, every SOAP message that contains the invoice will be having the invoice ID, because invoice ID is always unique, right? Or you can generate a static message ID as well, right? Fine. But the question is, how will the receiver come to know that what is the end, right? Can it wait for infinite period of time to receive 10, 15 or 50 invoices, right? It is not possible, right? So I need to embed a spatial ID with the last message, and that is called last message identifier. So the final message in a sequence is tagged with a last message identifier. Are you clear with this notations? Right? First thing is, every message has to contain a message ID, right? And the last message has to contain the last message ID, so that the receiver can come to know that now sender is not going to send anything, right? Are you clear with this? So that we can go ahead with the acknowledgements, right? Yes, okay. Fine. So now there are three types of acknowledgements we have. Let me just write down their names in chat box. The first is sequence acknowledgement. The second is, you can just remember these short forms, that will be helpful even for MCQs as well as for theory. Request acknowledgement and negative acknowledgement, right? Every acknowledgement is different in its own way, right? So let us start with the first one, sequence acknowledgement. So basically, reliable messaging provides us a notification system, right? And that notification is usually sent from RM destination to RM source. I hope you agree to this, right? Is there any point in sending the notification from RM source to RM destination? Just look at this figure. No, right? Ultimately, who has to respond for the success or failure or out of order? Yes, it is RM destination, correct. Yes, it is receiver, correct, right? So this acknowledgement system has to be written as a part of your RM destination, right? So what is sequence acknowledgement? Let us look at that. Upon receipt of the message containing the last message ID, RM destination issues a sequence acknowledgement, right? So until the last message ID is received, no acknowledgement will be generated, right? Sequence acknowledgement will be only generated after the last message ID is received. Is this point clear? Let me know if I am supposed to repeat, right? Is it clear? Yes, right? So why we are doing, or we are going for this kind of mechanism, right? Why we are sending a final acknowledgement only? Because we want to make our services loosely coupled, right? Okay. Now what that sequence ACK will contain, or sequence acknowledgement will contain, it will indicate to the RM source which messages were received. So suppose it was like this: 1, 2, 3, 4, and 5. This was the order in which the messages were sent, right? Now, if you received like this, 2, 4, and 5. Okay. So what your sequence SEK will contain? What your sequence SEK will contain based on this last definition? What did you understood? Initial order was 1, 2, 3, 4, 5, order of sending. But what you received is 2, 4, 5. So sequence SEK will contain message IDs 2, 4, and 5. Are you clear with this? Right? So based on this, the sender would come to know that message number 1 and 3 are lost. Right? So if required, if they were important messages, they need to be retransmitted. Am I making sense with this? What is sequence SEK? What is its importance? Are you understanding that? Right? Okay, good. Now, it is up to the RM source to determine if the message received are equal to the original messages or not, right? So now it will make a comparison. It will compare 1, 2, 3, 4, 5 with 2, 4, 5. And it will find out that message number 1 and 3 are lost. Okay. So who will do that? RM source. Agreed? It is the responsibility of RM source to determine that which messages are lost. Okay. Missing messages can be retransmitted if required. Okay. And obviously, will they be having the same message identifier, or now you will be generating a new message identifier? Suppose message number 1 was lost and I am retransmitting that. So will it be having ID as 6 or 1? What makes it more meaningful? It has to be same, right? It has to be same. Otherwise, how would again the receiver come to know, right? So this is called handling the sequence SEK. This is how we handle the sequence SEK, and this is how we handle the retransmission process. Okay, let us go for the example that will make you clear. So I hope you can see this dotted part. Dotted part is a sequence, and finally, once you receive the last message ID, you will be sending a sequence SEK. Right? Making sense? Clear with this example? Okay, good. Fine. So this is first type of acknowledgement. But see, there is one issue with this, right? What if I am going to send 100 messages, right? So in case of sequence SEK, I'll have to wait until all 100 messages are reaching the destination, isn't it? Because RM destination will not be generating the sequence SEK unless the last message is received. Yes or no? RM destination will be generating the sequence SEK only after receiving the message number 100. Do you agree with this, right? But what if the network is in a very bad situation and 70% of your messages were lost? So unnecessarily you would be wasting your time waiting for that sequence SEK. I hope you are getting the situation which I am describing. If your network is in a very bad situation, it might happen that 70% messages are lost, right? And you will come to know that after the 100th message reaches, right? So in between, should I be able to request for acknowledgement? In between, should I be able to? Yes, Priyank, that is another case, right? For that, we have one solution. We can keep, you can say timer, right, on the RM source. Within that time, if the response is not received, we can send the messages once again. So I think that can solve the problem, right? But let me go back to my question now. What if I want intermediate acknowledgements, right? Is that possible in this situation? If I'm going to use only, we can have some timer. So after that, yes, correct, Urjit. You can do that, right? That is possible. So For that, if you want acknowledgement at intermediate stages, we have the second type of acknowledgement message, that is called request acknowledgement, right? So now can you tell me who will be sending that request ACK? Or who will be requesting for acknowledgement, in other words? This is a confusing term, so that's why I'm asking. RM source to RM destination, you will be sending a request for acknowledgement, right? That's correct, right? So let us look at that figure and let me know if you understood or not, right? Within the incomplete sequence, right? The sequence is not yet complete. In between, I'm sending a request acknowledgement message, okay? And then I'm sending the regular message, okay? And once the RM destination receives that request ACK, it is bound to reply with an acknowledgement. And what that acknowledgement will contain? Can you tell me what this acknowledgement will contain? It is a reply of the request ACK. What it will contain? It will contain list of messages received till now. Is it true? It will contain list of messages received till now. Suppose you are sending, let us say 100 messages. So after every 25th message, you send a request ACK. After every 25th message, you send a request ACK. And what you expect in return? It will give you the list of messages which have been received actually. It is possible that out of 25, 5 might have been lost. Are you getting this or not? Right? Making sense, right? So, is this better or relying on the last sequence acknowledgement is better? Which gives us better reliability? This one, right? Request ACK is for group of message. Yes, General, that's correct. So as I gave you the example, suppose after sending message number 1 to 25, you are sending request ACK. So if everything worked fine, what your acknowledgement will contain? Message ID is 1 to 25, right? If everything was fine, right? But in worst case, it can contain just message number 1 and 25 to notify that between messages, or you can say message number 2 to 24 are lost, right? It is possible. We can't trust the network, right? So that is why we require this acknowledgement system, right? So why we have to take so much pain? Why we have to use this kind of acknowledgement system? Because we want to ensure that our services remain loosely coupled. Again, the same point. I hope now you are getting clear, right? Yes? Okay, good. Now, what is left? We have covered sequence acknowledgement. We have covered, you can say, in-between acknowledgement, right? What is the third requirement which we need to fulfill still? Anyone remembers that? Out of the 3, yes, correct, Priyank. Negative acknowledgement, right? So there is an option for that. Let us see how do we achieve that, right? RM source can request, okay, this is request, sorry. Negative acknowledgement can be issued by RM destination to immediately indicate the RM source that failure has occurred, right? So let us look at this. Suppose RM destination knows that it is going to receive 10 messages, right? Suppose, consider this hypothetical example. RM destination is aware that you are going to receive 10 messages, right? So after the first message is delivered, right, the second is not received for a certain period of time. Again, you have a timer for that, right, for receiving the second message. And if the second message is not received within a period of time, you can immediately indicate to the RM source that the message has not been received. So please resend and please check on your side. Okay. So can I say that negative acknowledgement would be increasing the burden on communication? Yes, correct. Right. But will it make sure that your communication is more reliable? Other side of the coin, will it make sure that your communication is further being reinforced? Yes, right? So this is also important, right? We should not always rely on the RM source, right? For sending the request for acknowledgement, right? Destination should also be capable of sending an acknowledgement that you have sent the message which is not received. Okay. But for this, what is the requirement? If RM destination, yes, correct, correct. RM destination must know that message is dropped in between, right? So I should know in advance what messages I'm going to receive, right? Yes. So you can say some or the other way, you need to let the destination know that I'm starting with a batch, right? And you let me know even if one message is lost. Are you getting that, Priyank? Yeah. So again, this can be used in combination with the sequence ACK, right? This acknowledgement can be used in combination with sequence ACK, right? Unless RM destination knows that your messages are out of order or what are the messages you are going to receive, you will never be able to generate negative ACK, right? So if I use these three acknowledgements, sequence acknowledgement, request acknowledgement, and negative acknowledgement, I am going to make the communication between services more reliable, right? And in the other words, I will be able to make sure that my services remain loosely coupled. Is this concept clear? All of you are clear with these three types of ACKs, right? Okay. Now, how we actually achieve this, right? We have to write the rules somewhere, right? We have said that the messages are to be sent in a sequence, or we have said that messages have to be sent only one time or multiple times. We have to write some rules, right? And those rules are written in terms of delivery assurances. Let us look at that definition. The nature of sequence is determined by a set of rules known as delivery assurances, right? Delivery assurances are predefined patterns that establish reliability policies. Okay, I think rather than looking at the definition, if I give you the terms, it will be more clear. If I say that, if I'm setting the rule as at most once, so what is the constraint over here? If the constraint is at most once on a SOAP message, what do you understand by that? Can I send a duplicate message if the reliability rule is set as at most once? No. Correct. Right? If I say at least once is the rule that I'm setting as a part of reliability rule, in that case, can I send duplicates? Is it possible to send duplicates in case of at least once? Yes. Right? Okay. If I say exactly once, right? If it is exactly once, can I generate duplicates in this case? Exactly once means what? Only one, right? Okay, good. Now tell me the difference between exactly once and at most once. If I am setting these two rules separately, what will be the difference? Exactly once and at most once. In at most once, if the message is lost, will that be acceptable? Yes, I think Priyank and Prince has written the answer already. In at most once, I can tolerate the loss of my message. Yes or no? I can tolerate the loss of the message. But in exactly once, can I tolerate the loss of the message? No. Correct. So if you are using this delivery assurances for banking transaction, which one will be useful? At most once, at least once, or exactly once for the transaction. I'll be showing you the definition, don't worry, but I want the concept to be clear first. Correct, exactly once, right? Because zero might also be a problem, right? Okay. So depending upon your requirement, you can select a delivery rule, and that rule has to be embedded in the node itself. That rule has to be embedded in the node itself. So node will define the rule, and based on that rule, your services will behave or your messages will behave, in other words, right? The last is obvious. I think you can easily guess. If I'm setting the rule as in order, what I cannot accept? If I set the rule as in order is equal to true, what I cannot accept? Out of order. Yes, correct. Right? Correct. So, using these four rules, we can handle the reliability in terms of SOA. Right? So, let us look at the definitions. Now, it will be very easy for you. At most once ensures delivery of 1 or 0 message. I think you are clear with this now, right? 1 or 0. Fine. It will generate an exception if more than one message are delivered. So if in your SOAP message, if you have written this rule that this message is supposed to be delivered once or 0 time, right? And if destination is receiving a duplicate, can it throw an exception? If the receiver is getting a duplicate message, can it generate an exception? Yes or no? I hope you are getting the situation, right? I want to make sure that 1 or 0 messages are delivered. So I will embed that rule in the SOAP message itself to let the receiver know that if you receive a duplicate, let me know. Okay. So if the message is failed also, will we be able to tolerate that? Or will we accept that in at most once? Yes or no? Yes, we will accept, right? So failed delivery would be acceptable if you are setting your rule as at most once. Okay, let us go for the second. At least once. At least one says that messages can be delivered one or more time. One or more time, right? So suppose when you are sending emails, right? Like newsletters. So can we send the newsletter more than one time? Right? If you are sending even it monthly, right? Won't we mind, or are we going to mind if the newsletter is received more than one time as a receiver? We won't mind that, right? Are you getting the example? Yes or no? If you are sending a notification or an email, if the message is delivered twice, that's okay, right? But we want to make sure that the message is delivered at least once, right? Suppose you are sending a job notification to the applicants. So if you are delivering that message multiple times or that email multiple times, that is fine. But what if the job aspirant is not able to receive the message, right? That will be a problem, right? Are you getting this? So in this kind of situations, we'll be using at least once kind of notification rule or reliability rule. Okay. Error will be generated if no messages are delivered. So if your SOAP message is written with a header where the rule is written like this, 1 or more, and then if you are not receiving a message for the second time, right? Let us say for first month you received, for the second month you did not receive the news, you can immediately let the sender know that I have missed the message, right? Okay. So is this diagram justifying this second rule? At least once. duplicates allowed, right? But missing not tolerable. Clear, right? With the second one. Okay, let us go for the third one now. Exactly once. Over here, we are being stringent. We are putting highest level of rule, that is, message has to be delivered once and only once, right? Error will be generated if zero or more than one messages are delivered. Okay, so this can be used for a banking transaction, right? Failed delivery is also not acceptable. Plus, duplicates are also not acceptable, right? Only one successful delivery is acceptable. Okay, clear with the third one? What is the third one? That is exactly one. Okay, good. Now let us cover the last one. In order. Suppose you are setting the rule in the SOAP header that I'm going to send my messages in a specific order only, right? So if in order is true, the messages are delivered in a specific sequence. Error will be generated if messages are delivered out of order. Okay, so you can just look at this. If message number 1 is sent, if message number 2 is lost, right, then message number 2 is getting retransmitted. Okay, but in between we have not written one acknowledgement. What is that? RM destination has to send an acknowledgement, right? That I have not received I have not received this message number 2. What will be that? Negative ACK. Will it be appropriate over here? Negative acknowledgement. We have just studied that earlier. Yes or no? Right. And what is the other way to handle that? The other way to handle that is you can send a request ACK in between. You can send a request ACK in between, right? And that request ACK, you will be waiting for the reply of that request ACK to make sure that your earlier messages are delivered, right? So anyway, you can customize this. But in order says that the messages have to be received in the same order of sending. 1, 2, and 3 are sent, then they have to be received as 1, 2, 3. Is it clear? Right? Yes. Now I'm going to cover one important difference, right? Then we will stop. That difference is between reliable messaging and addressing, right? In addressing, what we said was every message is having a unique ID, right? I think you remember we have a message ID header in MI header. Yes or no? We have a MI header known as message ID, and that message ID is usually unique always. Yes or no? Right? But this uniqueness will get violated in reliable messaging. Why? Read the last point, last dash that is written on this slide. Do you understand that or not? Addressing says that every message that you generate has to have a unique ID. I'll repeat. Addressing says that every message ID has to be unique. Okay? But what if the message is lost? Right? And if you are going with the rule of addressing, can you generate the message with same ID once again? Can you generate the message with same ID once again? No. Right? So actually, WS addressing standard was found first, and then when they researched about reliable messaging, they realized that sometimes we have to generate the message with the same ID because it has to be retransmitted, right? So that rule was changed after reliable messaging was introduced. Which rule? The uniqueness rule, right? So now it is possible that you can even regenerate the message with the same ID. Is this difference clear? Reliable messaging and addressing, right? Addressing earlier used to say that every message ID has to be unique, but reliable messaging added the rule or modified the rule that if a message is lost, I need to regenerate the message with the same ID. Okay. So are we all clear up to this? Reliable messaging? Okay, so thank you. Let us end this session for today, and we'll be covering the next topic, that is correlation, tomorrow, right? And that will be the end of your syllabus for the second session. Okay, correlation, and the next is policy. That's what we'll be covering tomorrow.